Hello dear participants, I welcome you all again here in this certificate course. In the previous few lectures, we have seen how to construct different types of tables like frequency tables, cross tables, stem and leaf display for different types of the variables. Moreover, we have seen that how to read and interpret those tables. Then we shifted to graphs or charts where we try to understand that how can we construct column or bar chart, pie chart, histogram using MS Excel and S.P.S.S. There also we try to understand that how to read and interpret those charts. In the recent lecture number 17, we tried to understand that what is the process to compute values for central tendencies, what is process to compute partition values, process to compute dispersion values, and process to compute distribution values, that is skewness and kurtosis using MS Excel and S.P.S.S. So the process part been already covered in the previous lecture. Now we'll try to understand the meaning of all these numerical methods, and then we'll go for the reading and interpretation part, reading and interpretation of those results which we have drawn in the previous lecture. So let me start with the meaning of first numerical method of descriptive statistics, that is central tendencies. So we all are here in lecture number 18, and title of lecture 18 is descriptive statistics, meaning of central tendency. Objective of this lecture is to make you familiar with the meaning of central tendency and its measures. There are different measures of central tendency. Here in this lecture we'll try to understand the meaning of those measures too. So let me start first with the meaning of central tendency. What is central tendency? Central tendency is a process to get a central value around which the group of values from variables are concentrated. What does that mean? When we collect data, as we all know, we are having different variables. Say that variable 1, variable 2, and so on and so forth. In each variable, we are having different values, different responses. Now, when we try to find out a particular value which represents the center of this variable, that value would be known as a central tendency value, and from each variable we can compute such value which represents the center of that particular data or which represents that variable. Fine. The central tendency is also known as the average value. This value plays a very important role in our analysis or in our interpretation, because this value helps us to compare with the other values. This value helps us to take crucial decisions in our research. This value helps us to give further statistical treatment, and it has a tremendous use in the statistics. That is why central tendencies are means they are playing very important role in the statistical analysis. Now let me take you to the measures of central tendency. There are different measures of central tendency. Arithmetic mean is there, median is there, mode is there, harmonic mean, geometric mean, and few more are also there. But at a very preliminary stage, we'll only focus on these three measures of central tendency. Now let me take first measure, arithmetic mean, and let me explain the meaning of arithmetic mean first. So what is the meaning of arithmetic mean? Arithmetic mean is the sum of all the observation values divided by the number of observation. Here all the values plays equal role, and here arithmetic mean is represented by x bar. It is denoted by x bar. Now let me explain you what is arithmetic mean. Suppose we are having one variable x and we are having different values like x1, x2, and so on and so forth till xn. So they all are the numbers, numeric, say that, suppose. Now if I add all these values, I'll get summation x. Here this summation, this is simply a mathematical sign which represents that you are adding all the x, fine, and this x is a variable. Now what is the formula for arithmetic mean? A manual formula for arithmetic mean is x bar is equal to summation x divided by n. So here summation x that we have computed here, adding all the numbers. What is n? N is a number of observation. So what is number of observation? Here is the first observation, here is the second observation, so on and so forth. Here is say that 10th observation. So number of observation is nothing but the responses, number of responses. Fine. Now if I divide summation x by n, I'll get a particular value, and that value will represent the center of this data. This value will represent the whole that data, and this value is also known as a average value. What does that mean? We'll see using one example in few upcoming slides. Fine. Now here you can see that I've used two terminologies again, sample mean and population mean. And if you remember, in week 1 we have used these terminologies where I explained that we usually compute this x bar from the sample data set, and on the basis of this x bar we make inference, we estimate for the population mean, that is mu. So usually we compute sample mean. Formula for sample mean and formula for population mean is same. For x bar, here is summation x divided by n, and for population mean formula remains same. Fine, there is no as such difference between these two. Only the meaning of this x bar and this meaning of this mu is different. This x bar is associated with the sample data and mu is associated with population data. This all part we have discussed in week 1. Now let me take you all to one example. Suppose there is one student who has earned marks in different 6 subjects, and we just want to compute central tendency. And in central tendency, first we'll compute arithmetic mean. How to compute arithmetic mean? Process part already we have seen in the previous lecture, so I will not spend much time here on that process. Average function I'm using, I'll select that range and I'll compute this arithmetic mean. Here arithmetic mean is 60. So how to interpret this? How to read this? What is this 60? 60 represents the average marks. What does that mean? Average marks means that particular student have earned different marks in different subjects. But I'm not able to understand that where does he stand. And for that we have computed arithmetic mean. Using arithmetic mean, I have got a value 60, and this 60 represents me that fine, that student have earned averagely 60 marks in each subject. But in actual, there are two subjects where he has earned less than this 60. There are two subjects where he has earned more than this 60, and there are two subjects where he has earned exactly equal to those average or that arithmetic mean. Fine, but still this 60 represents the whole data, and it explains us that that student have earned averagely 60 marks. So this 60 comes from the center of this distribution. So this is the way that we interpret arithmetic mean. Arithmetic mean represents the average of that distribution. Now how to compute this arithmetic mean manually? To compute it manually, we'll use this formula, x bar is equal to summation x divided by n. Already I have explained you what is summation x. Summation x means we added all these marks, and here is the total 360 divided by number of observations. First observation, second, third, 4, 5 and 6. There are 6 subjects, is equal to I'll get 60. So if you are computing arithmetic mean manually, you will have to use this formula. But usually if you are having MS Excel or S.P.S.S, there is really no need to go manually. All this work will be done by the softwares, and they'll directly give you the output, the results. Fine. So this is the way that we read and interpret arithmetic mean. Now let me take you to the further measure of central tendency, and that is median. What is median? Median refers to the middle value in the distribution. It is a value located at exactly 50th position of the distribution, and that is why this is called positional value. This is a positional value, locational value. Fine. Median value split the distribution into exactly equal two parts, 50% either side. What does that mean? Suppose I am having data. This data is here, and it starts from 1 and it ends at say that 100. Just example. Now there are some formula of median using which if I compute a particular value and that value it stands here exactly at the 50th position. Fine. So that value represents the median, above which there is a 50% distribution and below which there is a 50% distribution. So this is the middle value at the mid of that data, that would be known as a median. Arithmetic mean is the average value. Median is the central, or what I would say the exactly mid value. The difference between two is median is a positional value, whereas arithmetic mean is not a positional value. Now let me just read the last statement. When n is odd, the median is an actual value presented in the distribution, and if n is even, the median is derived figure. What does that mean? Let me tell you. Suppose here is x and 1, 2, 3, 4 and 5. So there are 5 numbers. What would be the median? When we'll use one formula that we'll see in the upcoming slides, but when I'll use the formula, then I'll find that this 3 is a median, above which there are two numbers and below which there are two numbers. It means here is a 50% distribution and here is a 50% distribution, and this value stands at, or this value is exactly at the mid of that data. Now take other example. Suppose here is x, 1, 2, 3 and 4. There are 4 values, and if I use a formula to compute median, it will come somewhere here 2.5th item. Fine. And so I'll have to derive again. So I'll have to combine 2 plus 3 divided by 2, 5 divided by 2, 2.5. Fine. That is why if your number of observation is even, then median would be derived figure. But if n is odd, then median is an actual value, and that is presented here in the distribution. It is visible. This value is visible. Now to understand this in a better way, let me take you to one example. The same example we are using to compute median here. Simply I'll use a function or a formula median. I'll select the range and I'll get the median. Process part already we have covered in the previous lecture. Fine. How to compute it manually? To compute it manually, formula is median is equal to size of n plus 1 divided by second item. Then what is n? N is a number of observation, 1, 2, 3, 4, 5 and 6. So 6 plus 1 divided by 2 is equal to 7 divided by 2 is equal to 3.5th item. Now here is the 3.5th item. Fine. So here is 1, 2 and 3. Here is 3. 3.5 it comes here in between these two numbers, but this is a discrete. All these are discrete values, so 60 and 60 there is no difference between this third and fourth value, so it comes 60. So this is the way that we compute median. And what is the meaning of this median? How to interpret this? Now this 60 is the value which is located here in between this, and this 60, let me explain you again. This 60 is exactly located in the mid of this distribution, above which there are these three values and below which there are these three values. So this is a positional value. It is somewhere here. Fine. So this is the way that we interpret median. Now let me take you to the mode. What is mode? It is a value with highest frequency in the data set. It is a value with highest frequency in the dataset. Mode of a distribution is the value at the point around which the items tend to be most heavily concentrated. This is a definition by Croston and Cowden. There are different types of mode: unimodal, bimodal, or multimodal. Now let me take here one example. Say that here is a gender C 0 0 0 0 1 1. So here simply by observing the data, who is having the highest frequency? 0 comes 4 times and 1 comes 2 times. So 0 is my mode. Mode is the highest frequency. the value with the highest frequency. Fine. And if 0 is associated with, or 0 is a code assigned to male, it means for gender C my mode is male. So this is the way that we go with the mode. Now let me take you all to the example. Here in this example, how to compute mode? Simply the process that we already have seen. We have used mode formula and it came here 60. What does that mean? It means 52 came once, 56 came once, 60 it came twice, 64 came once, 68 came once. So which value comes with the highest frequency? This value 60 comes with highest frequency, that is why 60 is mode, and 60 simply represents what? 60 marks. These are the marks, which marks that particular student have earned in maximum subject with highest frequency. Fine. So this is the way that we interpret mode. Now how to compute it manually? To compute it manually, formula is mode is equal to simply by observation. So observing these things, I can find that yes, 60 is with the highest frequency. That is why mode is 60. So this is the way that we compute mode. Now let me take you all to the distribution. So this, here are the marks of a particular student. Here is the distribution, graphical distribution. Now this circle is, it is showing 52 marks, correct? This is 56. There are two 60 marks. Fine. Here is a 64 marks and here is a 68. So this is a distribution. And from this distribution, where is my mean? My mean is here. So here x bar is equal to 60. My median is also 60. So my median is also 60 and mode is also 60. So my mode is also 60. Fine. Now let me take you to the further slides. So this was one example. Now let's consider case number 2. Now here there is a other student and he has also earned different marks in different subjects. Now let us compute mean, median and mode here. When I'll compute the mean will come 60, median will come 60 and mode. What would be the value here? If you remember, what is the formula for mode? The manual formula by observation. Is there any value which came with the highest frequency? 52 came once, 56 once, 58 once, 62 once, 64 once, 68 once. All values, they came only once. There is no single value which came with a highest frequency. That is why if I use this function and if I enter, I press enter, you can see that the error message comes. Why error message comes? There should be at least one value which has came twice or more than twice with the highest frequency. Otherwise, it will give you error message. Now, if I compare these two numbers, see the average is same, median is same. Whether the students case 1 and case 2 are same, are they the same student? They are not same student. Even the distribution is different. How is the distribution? You can see that here in case 2, how is the distribution? Here is 52, here is 56, here is 58, here is 62, here is 64, 68. What is my mean here? 60. My mean is 60. What is my median? Median is 60. And here you can see that this 60 is not there in this data. That 60 is not there. Still, I got the mean. So it is not necessary that your arithmetic mean is present in data. It is not always necessary that your arithmetic mean is visible in the distribution. In some cases, your arithmetic mean, it is not there. It is not visible here in the data. Still, we find the central tendency. What is central tendency? So this is the distribution. So we try to find out central value. Fine. And in central value, again there are three different measures: mean, median and mode, and they are having their own meaning. So whatever you compute, if you compute mean, you will have to explain accordingly. If you compute median, you will have to explain accordingly. If you compute mode, you will have to explain accordingly. Fine. Now if I compare these two distributions, here yes, mean, median, mode are 60. Here mean and median are 60. But there is a difference in the distribution. It is not necessary that means to get the same values, your distribution should be equal or homogeneous. It is not necessary. Though the distribution is not homogeneous, still there are chances that you will get the same mean or median. Fine. There are chances that you will get the same mean or median. So here the distribution thing is here. Now let me take you to case 3 again. I'll compute mean, median, mode. If I compute mean, median and mode, then again here you will find that mean and median, they are same in all these three cases. Again here mode, I will not get mode because there is not a single value which came with the highest frequency. And now if I go further and if I compare or if I just see the distribution, you can see that extreme less numbers, extreme less marks and extremely high marks, but still we try to compute what? Central tendency. And that is why we get mean and median 60. Why we are not getting mode? Because there is no single value which came with the highest frequency. Now here, so far the median is concerned, what is median? 60. That median is not here. How we computed median? N plus 1. N plus 1 divided by second item. That is 6 plus 1 divided by second item. That is 7 divided by second. 3.5th item. Now where is 3.5th? First, second, third. 3.5th is somewhere here. Fine. How to compute this? To compute this, 48 plus 72 divided by 2 is equal to 48 plus 72, 8, 9, 10, 8, 9, 10, 11, 12. It will be 120 divided by 2 will be 60. So this is the way that we compute median. So 60 marks are located somewhere here. And this 60 marks tells me, this median 60 marks, it tells me that there are 3 numbers above this 60 and there are 3 numbers below this 60. So this is the way that we interpret median. Now let me compare all these 3 cases. For all these 3 cases, mean and median are 60, but look at the distribution. Here in case 3, we are having extreme values. Still we are getting the central tendency 60. Here and in this case, again we are getting the central value 60. Though the distribution is different, we are getting the same mean, median or mode. Now let me take you to the last example. Here again case number 4. Suppose there is a student who has got exactly 60 marks in each subject, and if I compute mean, median and mode, what would be the answer here? What would be the mode? Mode would be 60 because 60 came 6 times. Here we find the mode. Fine. Now if I compare all these 4 cases, if I go ahead, how is the distribution here? He has got 60 marks in each subject, so here is the mean, here is the median and here is the mode itself. Now if I compare all these 4 cases, if I go little ahead and if I compare all these cases, in all these 4 cases my mean, median, they are same and mode is also same here in these 2 cases. Fine. So this is the way that we interpret mean, median and mode. So it was a very small data set. Usually when we are having variables with us, we are having plenty of responses, like 340 respondents are there or 460 respondents are there. And for that many responses, when we compute mean, median and mode, then it becomes very interesting to analyze them. Fine. So this is the way that we read the result for mean and median and mode. Now here are few questions. Whether the value of arithmetic mean always be visible in the data? This 60, it is visible here. This 60 is not visible here. It is not visible. This 60, again it is not visible. This 60, it is visible there. Fine. So it is not necessary that always that your arithmetic mean is visible in the data. It is not always necessary. Whether the value of median always be visible in the data. For the median, again, this 60, this median is here. This 60, it is not here. This 60, again, this is not here. This 60 is here. Though I am saying that this 60 is not here, but the way I have computed this thing, this 60 is somewhere between these two values, and this 60 is somewhere between these two values. That is why, though it is not visible, we consider 60 as part of this data, this distribution, and we consider 60 as the mid. It is the middle value, mid of this distribution. It has stood at the 50th position, exactly at the mid of this distribution. That is why, though it is not visible, it is there, that we assume. So this is the way that we explain with the median thing. Now third question, whether the value of mode always be visible in the data. Let's see. Here is the mode. If we have computed mode, yes, mode is here, it is visible. Now here is an error message. Why? Because no mode is visible here. So if we are getting error message, then that mode is not visible here. If your mode is here, then mode is visible actually. Fine. So the value of mode is always visible in the data. It is always visible. Which measurement of central tendency considers all the values in its formula? If you remember, x bar is equal to summation x divided by n. Median is equal to n divided by n plus 1 divided by second item, and mode is equal to by observation. Fine. Now here we add all these things. In mean, in median, we just count the number of observers: first, second, third, fourth, 5, 6, 6 plus 1, and then we compute some positional value, some position. We don't add anything, right? And in mode, we just look at the data and we decide that who is having the highest frequency. So mean is the arithmetic mean is the measure where it considers all the values in its formula, and that is why we give plenty of statistical treatment on arithmetic mean, and that is why the arithmetic mean is the most popular measure of central tendency. So even in the future, means the further lectures, even in during this course also, we'll be using arithmetic mean many times. We'll be using arithmetic mean many times for the further statistical treatment. Fine. So which measurement of central tendency represents the position? So position is associated with the median because it represents the position where it is located at the 50th position, right? And which measurement of central tendency represents the highest frequency? That is mode. Mode is with the highest frequency. So always remember three things. Mean is actually the popular average value. Median is a positional value with 50th position. Mode is with the highest frequency. So whatever number you get, you will interpret this number accordingly, considering the meaning of mean, median, and mode. So here is our data on which we have computed mean, median, mode, and other things. Fine. Out of that data, if I consider age, age is one variable on which we already have computed mean, median, mode in the previous lecture. And if I draw a kind of a chart or a graph here, each this circle represents all these responses. Now what we try to do here in central tendency, we try to find a central value. Central value means from this place somewhere I try to find my mean, my median, and my mode. And central value, why we are trying to find a central value? Because the central value will represent the center of data, and it has its own meaning, and it can help us to take some research decisions. Fine. So this is the way that we work with the mean, median, and mode. So far this lecture is concerned, we'll stop here. In this lecture, we try to understand the meaning of central tendency. In the next lecture, we'll go and see that how can we read and interpret the outputs which we have computed in the previous lecture on the data which I have shown just in the previous slide. Fine. So let's see reading and interpretation in the next lecture. Till then, we'll stop here. Thank you for your kind listening. Thank you.